chatter to a minimum unless you're asking them a question. So if you want to order something, try to do it quietly. We usually bring paper and pencils, but you know, it's the end of the semester, I forgot. So again, thank you all. And Scott is going to talk to us about everything you always wanted to know about hydrogen, but we're afraid to ask.
There you go.
So.
Thank you very much, Renee. I'm happy to be back. I love doing this. It's one of my favorite things to do around campus/town. Today I'm going to talk to you guys about hydrogen. So you probably heard about the promises of hydrogen for a long period of time. Like when I was talking to my cousin Matt just a minute ago. When we were kids, oh yeah, everything's going to be hydrogen. Still isn't there yet. Why isn't it there? Yeah, I wish we were at the metric system. One of these. Then my dad and I wouldn't get into fights over out of the old things. All right, so an overview. This is going to be an outline of the talk that we're going to talk about. Why should you trust me? Why hydrogen? Good things, bad things, and solutions. There will be some flames intermittently throughout this. So please be prepared. I will need a volunteer at a point, and we're going to mess around with the dark. Don't take that literally. All right. So why should you trust me? Well, the government has given me $500,000 of your taxpayer money. And I still haven't decided if I'm going to leave town and burn it all on jet skis yet until they catch me. But otherwise, I have 30 peer-reviewed publications, got multiple grants. I'm an external reviewer for the Department of Energy, so I see a lot of other things that go through in terms of hydrogen, not just my stuff. So let's get right to the flames and the fun, okay? So I have a shameless plug. So the NSF, the National Science Foundation that gives me money, doesn't care if I generate proprietary information from my research, and I got a really good one. So think about when you were a kid. What did you want to play with the most? Fire! I loved fire as a kid. You know, it was great. You know, you know who it is?
You.
No, anybody watch the series Dahmer lately? Yeah, young kids love playing with fire. Roadkill too. Anyways, what I've been working on is a new toy designed for children. It's called Fire Bubbles, and I'm going to demonstrate it here today. I am going to need a volunteer. These are the pieces of artwork that I'm working on right now to try and sell this thing. Okay, the real spot, I used an AI to generate these images. My favorite one is the arm coming out of the child. But these are the least disturbing ones. These are the most disturbing ones. This one came from Haiti explosion. A toy kid on fire, fire bubbles and face melting. All right, but what this toy completely depends on is the reaction of hydrogen with oxygen. So I now need a volunteer. Anybody at all? Oh, Christine! Volunteer! All right, what you're going to do, you're going to put on some of these gloves. Okay? And what I'm going to do, I'm going to generate some bubbles. Okay, so the way we're going to generate the bubbles, I've concentrated hydrochloric acid. This is perfect for a children's toy. What we're going to do is we're going to generate some hydrogen gas from a redox reaction or an oxidation reduction reaction, and we're going to trap the hydrogen in some bubbles. So there's some soapy water over here. Okay? We're going to make some bubbles. Christine, can you put one of your hands over in the side I'm not generating bubbles in? Yep, just put it right in there and rub it against your other hand. That makes it so it's easier to scoop up the bubbles.
Rub it.
And now I need a volunteer to turn off the lights. This is where it's going to get interesting. All right. And now what I want you to do is try and scoop up those bubbles. Let's see if you can do it in the dark. Okay, ready? Now hold it out that way. I want everyone to be quiet. Ready? 1, 2, 3. All right, let's do it again because I got a lot of this stuff. Yeah. See? Children of all ages love it. Generate some more.
I should have asked what the danger to me was.
Not much. Probably. You probably have more danger with the soap on the floor than anything else.
Don't worry, you won't get burned on this deal.
Uh-oh.
All right, go ahead, scoop some up. Let's try and do it again. Get away from the bubbles. Ready? How hot was it?
I could feel the warmth.
Yeah. You feel the love? We can turn the lights back on. All right, well, everybody give Christine a round of applause. So, here, I'll help you out. There we go. So, I think it'll sell great. But that's one of the points behind hydrogen. It's explosive. We can generate energy from it. We can store energy in it, which is nice. The other good thing, so for people who don't know what this is a chemical reaction. You have hydrogen plus oxygen gets you, what's this thing?
Water.
Water!
Water vapor.
Great! It's a product.
Wait, what's the G?
Gases.
Okay.
So, now let's talk about like where is hydrogen currently being used? Where's it going to be implemented? That sort of stuff. So the big push is actually for hydrogen fuel cells. What a fuel cell is you basically cause a chemical reaction and you generate electricity from it. In this case, we're pumping in hydrogen, you pump in oxygen, you get water out, and you generate electricity. It's one of the most efficient ways to generate electricity. Other spots that people are working are actually on combustion engines for hydrogen. Those are not as efficient as these fuel cells. The reason people are doing it, we're using that technology. If you think of your gas engines, they all work based upon combustion. So it doesn't take much to really change it. So cars, there are certain car manufacturers like Toyota, BMW, this guy's a BMW. What is it? I think Nissan's trying to develop one right now. They're all focusing on trying to do that. Okay, this is a really interesting one. So this is an apartment complex in Tokyo, and this thing right here is one of those fuel cells that we just talked about. This is like a small power plant. It generates enough electricity for the entire apartment complex. The other classical spot that you'll see is for big transportation. So for planes, shipping containers, this is the first hydrogen-powered train in Germany. And that guy up there for heavy trucks, they're focusing on that primarily because it makes more sense for these big, heavy things. Hydrogen's really, really light. And it makes sense if you're trying to transport big, heavy stuff that this can work out. Okay. Another incredibly important spot, but I feel like people don't really appreciate, is this chemical reaction. Okay. Don't answer chemists. Does anybody know what this reaction is? Okay. Chemists, can anybody tell me what is this reaction? Yeah, what was it? Haber-Bosch, yes, the Haber-Bosch process. Okay.
Good job, Dennis.
You're rehired, you're good. Fun parts of being department chair, right? Okay, so why is this reaction so important? Well, this plot can actually show us. So what we have on the y-axis is the population of the world. On the x-axis, we have time, what year we're currently in. And you can see all of a sudden, bam, population shoots way up. And that's when this Haber-Bosch process was industrially implemented. It's not because of broken condoms. Don't worry, we'll talk about that soon. Okay. So that specific process led to almost a large amount of fertilizer, which increased the world's population through feeding people. And Fritz Haber, this is one of my favorite pictures or animations of him. He won the Nobel Prize for this discovery, but a lot of people didn't attend his Nobel Prize ceremony. He is known as the man who killed millions but generated billions.
Oh.
He is the reason in World War I that there was chemical warfare. He was the main driver behind it. So, kind of interesting. And even though you may hate his implementation for war, you don't have much to say. You're a fucking hypocrite if you're against it. You want to know why? 80% of the nitrogen in your body is due to this process. So, if you look, these are all the different elements in the human body. So,
Scientists
thank you. Well, you know what? I love dichotomy. I love finding hypocritical people. That's great. I'm one myself, though, so it makes it more fun. All right. So let's talk about why hydrogen. All these people, all these processes. Okay, makes sense. Yada yada. We're going to talk about availability, something called energetic density, and the greenness of it. So the big one we're going to approach is availability. So what this is this is a plot of relative abundance of elements across the universe. And you can see, looking through here, blue is hydrogen, that red bit is helium, and then everything else is that little sliver. Yeah?
But like I hear that helium is like starting to get scarce or something.
It is on Earth. The reason is helium, along with hydrogen, is one of those few gases that can escape the atmosphere. And once it does, it's gone.
But Christine, we can get all we need just by diving into the sun, so don't worry.
Yeah? That's what you put the grad students on to do first, right? Okay, so there's a lot of it in terms of the universe. If you look at our small microcosm, this is a cool rotating picture of the globe. I love animations. What do you notice most of the surface of the planet's covered with?
Water.
Water, huh? Blue, yeah, it's my favorite color. Okay, and you can use water to generate hydrogen. That's actually what I'm doing up here in this little vessel. So I'll set it back up after we make another boop happen or explosion happen. It's currently generating hydrogen through electricity. Does anybody know what this is? No! It's a European freezing the fuck to death because Russia turned off their gas! Okay? It's a huge problem. Why is Germany focusing on generating hydrogen? Why are countries like Japan and the UK looking at it? Let's look at UK. What do you notice it's surrounded by?
Water.
Huh. This plot over here is of oil production. We got annual oil production on the y-axis, year on the x-axis. What do you notice about their oil production? Going down. Doesn't it make sense for countries that have very limited oil reserves to look at different energy sources?
Yep.
Especially ones where you can literally scoop it up by what you're surrounded by. All right. So I promised you I would talk about broken condoms. Let's get there. So I like to always do a lot of really in-depth dimensional analysis in my talks because I think about these things. I don't know. I didn't have much to do when I was a kid, I guess. So we're going to ask how many hydrogen atoms are in one drop of water. We're approximating a drop of water to be that many milliliters. What we're going to first do is assume the density of water is 1. That happens at one specific temperature. Don't yell at me, chemists. If we take the molecular weight of hydrogen, we can get into something called a mole. That's like a baker's dozen for a chemist. It's just a number of items. We can turn that from water to moles of hydrogen. And from that, we can get to atoms of hydrogen. So how many items are in a baker's dozen?
13.
13. Okay, in a mole, there are 6.022 times 10 to the 23rd of those things. So that's where that number comes from. All right, when you generate that, that's how many hydrogen atoms are in one drop of water. Okay, so now, onto the condoms. Okay. Given that the failure rate of a condom is around 2%, How many children will we expect from that many times? That's immediately where I went to. We recently had a child. Just kidding. Alright, so we're gonna turn our condoms into pregnancies, okay? So let's do that. That's how many pregnancies you get. Does anybody have any idea what that number like means?
A lot.
It's a lot. Okay, so that's just pregnancies. Let's get them to kids. So, want to go back to this slide? Sure. So that many pregnancies.
Guess he ain't kidding around.
Okay, so 10 to 5, 15% of pregnancies end in miscarriages, so we're going to X them out. Less than 1% have twins, this many have triplets, this many have quadruplets. That leaves approximately this percentage for single birth, okay? Jimmy? We're not including those ones in this count.
Holy
These are based upon reported births. Or excuse me, reported pregnancies. So we don't know that actual number, but we'll get there. Okay, so I get the math. Blam! This is how many babies we end up with. Okay, way more than you would think. Okay, now, does anybody know the German industrial band Rammstein? Yeah, I love Rammstein. They're my favorite. They recently released an album called Zeit, which stands for time. There's also a song in it. And in their music video, it's really trippy. They talk about like how you only have so much time left and yada yada. So I started thinking about humanity and time and got really, really deep. It's not good for me. So how big is that? First, we want to put this into the amount of people who have been born. So based upon some speculation, they have assumed and have some good numerical data suggesting that 117 billion people have lived or died. Okay, so that's all of humanity. So now what we're going to do is we're going to take how many babies we've generated, we're going to figure out how many humanities that is. We do that, blam. We get around 500 million humanities. So think about that in your terms of water droplets, and 2% of the hydrogen in that water droplets encompasses that. It's an astronomically huge number. Really hard to fathom. Sorry, I really like both of those spots. Another fun one, since it's around Christmas time, why not? We got a Christmas comment. You gotta watch. Okay, so let's get back to what I was meant to be talking about. Hydrogen energy density. So energy density is a way you can measure how much energy is packed into something. So what we got is a really complicated plot. I will try my best to explain it. On the y-axis, we have volumetric density. Basically, what this tells you is that gets higher the less volume you take up per unit of energy. Okay? And then on the gravimetric density, it's how much energy you can generate with a small amount of mass as that number increases. So we have all the conventional types of fuel that we have up here. The big ones I want you to focus on are hydrogen, diesel, and gasoline up there. Okay, so gravimetric density, hydrogen is awesome.
Wait, didn't you just say higher up is the more space it takes?
It's less space it
That's what I mean, less
Right,
space.
so that's the good point of hydrogen. What's the bad point of hydrogen then? Takes up a lot of space. Currently, with the technology that we have, there are people working on this thing. Okay. Next, the green idea. So what green means is you don't harm the planet. It comes from renewable resources. There are actually many different colors of hydrogen. The hydrogen itself isn't a different color, but they brand it based upon different types. My favorite is pink or red, which comes from nuclear power because you make a lot of it. Green is the best solution for our planet, though. There's also blue, which my older brother likes because he works at ARG and he's an oil man. Gray is also really not good for the environment, but this is blue and gray and black are the main ways hydrogen is currently generated for the most part. So how can we make this renewable though? You can take renewable energy, you can set up an apparatus like I have up front here. You can generate hydrogen from it, you store that hydrogen, and then you start using it and stuff, okay?
But isn't that kind of an exchange of energy for energy?
Yes, 100% is. But, yep, but how are you gonna store the energy? So our options right now are lithium-ion batteries, which come from mining and all this other bad stuff. Or we have hydrogen, which we're gonna talk about the bad spots about hydrogen.
Lift water.
Yeah, with water.
No,
And-
lift water.
Oh yeah,
That's
actually,
another way to say it.
yeah, you can just keep it as a water form until you need it too. That's what a lot of people, or I'm sorry, with water, I'm sorry.
Lift water, like, if you wanna store energy, just lift up
Oh,
water.
yeah, actually, I've seen a lot of stuff about that too. It's cool. The other benefit to it being green, out of all the oxidation that you do with this stuff, you end up with water, which we showed with our little experiment over there. So water is the outcome, and it goes back to water. Continually, I know.
There we go.
And we have a lot of water on our planet. Might not be clean, but we got a lot. All right. Let's talk about the bad stuff. These are the main issues with gas storage in general, but it can be centered around hydrogen. So, the major problem. Does anybody know what this picture is? Challenger explosion. Okay. Does anybody know why that happened? That O-ring, you had compressed hydrogen, compressed oxygen on a vessel going really fast. Why are we doing that to our astronauts? Because it's the best we got right now. This one's a pretty classic. Hindenburg, yeah. There's a lot of conspiracy theories around that one. Does anybody know about this one? This is a hospital at the beginning of the COVID pandemic. This is oxygen, compressed oxygen. Their system exploded, leveled that part of the hospital. So big point, current gas storage is not safe. Okay? The tanks that we use, there's a reason, like when you go into our labs, they're strapped onto stuff, they have safety canisters around them, all sorts of things. Okay, next thing. These are a bunch of different hydrogen sources that we have. This is the gravimetric density of those situations. What I want to point out to you is the gases at these bars in the liquid one, that's the conventional way hydrogen is traditionally stored. We haven't explored enough on how to keep this stuff around. So another big point is we're at the lower limit right now. It's going to get better. I like the songs, it makes me feel good too. The other aspect of this is what's known as blow-off. So if you work with cryogens, liquid nitrogen, liquid helium, what happens is they constantly degas. So as you sit there over time, you're going to lose more and more and more of this stuff. So every day, if you have what's known as a canister, a liquid dewar full of this stuff, you're going to lose 2% by it just sitting there. So that doesn't sound too good. Okay, the other spot, which we kind of alluded to, or Christine reading the graph knew. All right. This is just a plot I made where we have the tank weight, so what we're trying to store versus the tank volume. This is the area that we need to hit to make transportation a real life thing. Once we hit this zone, bam, where gasoline is, life is good. These other methodologies aren't quite there yet. So that's why we're all not driving hydrogen cars around. Shit blows up, takes up too much space, too expensive to generate. Okay. So what about the frontier? What are people trying to do to quell these matters to get there? This is just a cool graphic. I'm going to talk about some specifics in here. One, a selfless, shameless plug for what I'm doing. So the one avenue I'm trying to explore is called the molecular corking effect, where you have hydrogen and a metal surface. What happens is that hydrogen meets the metal surface, breaks apart into atomistic hydrogen. That might not seem like a big deal to you, but in terms of a safety concern, that's huge. This stuff doesn't explode. It's safe. The problem with it is it can meet right back at this atom, pop off. And that's where we toss in another molecule and we can trap it there. And experimentalists have shown that you can raise the temperature a significant amount. We're working in the Kelvin scale, 60-ish degrees, 50-ish degrees up. However, what do you know? So this is without a cork, this is with a cork. What do you know about this temperature, though, those who know about the Kelvin scale?
Pretty cold.
Yeah. I wouldn't want to be naked out in these temperatures. It's pretty cold. Still not where it needs to be. So the big part is we have really low temperatures, and we try to drive that temperature up, make it useful at what we can experience. If you're interested in that, read my paper, come talk to me or Matt. We'll tell you a lot about it. So pros and cons, you can tune it to what you need. Gas is stored completely safely. The cons, you have to reload it with that molecular cork, that molecule that sticks on, and it's not well studied. Hence why the government gave me a bunch of money to look at it. Okay. Another cool thing where people are trying to utilize to capture these gases are known as metal organic frameworks. So what they are, think about it like a net. And the gases traveling get trapped by that net. So what this is, these are a bunch of oxygens, carbons, and some metal, and they actually suck in that hydrogen and store it. And then what you do is you heat it up, and it drives that hydrogen off. And it leaves that network, that net behind. So it's reusable, which is cool. So what I'm showing here is a molecular dynamics simulation. That's where the atoms move around. You use physics to figure out what's going on here. Yay, physics. All right. So pro to it, it can store gas safely, just like the molecular corking effect. It's really well studied. Most of your government taxpayer dollars relating to hydrogen go towards studying this stuff. The downside to it is most of your money has gone towards this. How many of you have ever gone to the store to pick up a metal organic framework? It doesn't work. Okay. The other thing is it has to be reloaded. That's kind of all. Okay, another spot you can look at are metal hydrides. This is where you take metal and you squish hydrogen into it. My advisor gets paid lots of money up at UB, making way more than I could ever hope to. She studies that sort of stuff. Gets incorporated into metals. The crazy thing to make these, though, you need some really technical equipment. Does anybody know what those things are in the top?
Diamonds?
They're diamonds.
Not made or real diamonds?
Oh, they're man-made. Yeah. But what do you know about diamonds?
They last forever.
They're expensive. That's where I don't know where you guys are at. It costs a shit ton of money. Okay? Oh, my wife, that was an expensive money. Diamonds. Okay? You have to use diamonds to squeeze this stuff to make it. And guess what happens like 8 out of 10 times when you squeeze stuff at that high of pressures? You break the diamonds. Yeah. So
Then you sell them.
it doesn't work well. There is a lot of funding for the DOE for this too. Actually, the national labs, every national lab across the country that relates to the DOE is studying this stuff. It works pretty well. They're doing it for other reasons though, some chemical reasons to make chemical reactions happen that shouldn't, but part of it is hydrogen storage. So the downside to them though is they're often heavy and diamonds. The last one has to deal with what are known as hydrogen clathrates. So how about we use water to trap this stuff? I'm going to try to pull this up. I don't know if I can get to it. But clathrates are pretty cool compounds. Like this. And what they do is they can trap gases. You have networks of hydrogen that suck in a gas. These exist at the bottom of the ocean. Oops, it's not up there.
You might have to
Why are you guys looking at me?
stop, share, and reshare.
Can I bring it over? Yeah, there we go.
Oh.
Oops. Okay, so this is ice on fire.
That makes sense.
Yeah, so what's happening here, they're flammable gases that are trapped in that ice, in that network of ice. And you can actually use ice as the transportation device.
It's like my bubbles, except in ice.
Yes, exactly. Connections. That guy looks like somebody who's studying plant reeds. All right. This is the guy with crazy hair talking about hiding. All right. Anyways, so the pro to this, it's lightweight. The storage capacity is awesome. To store it, you need renewable resources. The biggest problem is they're generally not stable at ambient temperature and pressure. Ice doesn't like to exist at room temperature. Try to make an engine to burn the stuff, not going to work out too well. The other thing is it's really sensitive to temperatures and pressures, so if you're trying to make it uniformly, it's not going to work. So let's talk about the outlook of hydrogen. So this is the amount of hydrogen that's being generated in megatons. On the x-axis we have time. You can see that it's going to go up. Most of this going up is actually for the fertilizer, the Haber-Bosch process. But what they do believe in terms of other energy output, the stuff Europeans are focusing on in a lot of these island countries, they're going to need hydrogen for their fuel sources. That's where it's going to have to go. Okay. So we'll do one more explosion, but before that, I want to thank everybody who helped me out. AJ helped me find all this stuff today that we're going to do in a second. I'd like to thank Dr. Matt Hansen. He helped study this stuff. Kate Merkel, I think I saw her. Yeah, Kate works on this stuff. Will Wozniak, and if you guys know Mike, he graduated last year. He helped me work on this stuff. So, so let's finish it off. What I have up here is the Hoffman apparatus. I'm going to try to move it around. You can see gas bubbles have been generated all throughout our talk. One of these contains hydrogen in it, and one of them contains oxygen. We're going to figure out which one contains which. Okay? So, yeah. Oh wait, my flamethrower's over there. Okay, so, hey, thank you. So the oxygen, all it will do is it'll make the flame burn a little bit brighter. The hydrogen will make an audible pop. We got to go kind of quick because as soon as I turn these over, the gas is going to escape. Here, do you want to hold fire for me?
No, okay.
Okay. Here, you should wear safety glasses, probably. Safety third. Yep, turn around, hit it. Okay, and what I'm going to do, I'm going to flip this over and get it close. Ready? That's the hydrogen. The other one's the oxygen. It's not going to do too much that's exciting, but let's go for it. Anyways, this fire's cool.
Did you know before you took it out?
I should have. That one's oxygen. Okay. So if you want to check this thing out, it's generating hydrogen and oxygen. I'm sure we could do it 1 or 2 more times, but for now, that's all I got. Thank you all for listening. I'd be happy to answer any questions if people want to ask me something. Yeah.
Yeah, so you opened your talk with this, why should we trust you? But the problem is, I still don't trust you.
Don't worry, I got a beer. I dealt with some fire. Nobody died.
Yeah.
Pretty good in my book.
Yeah, I'm convinced.
Yeah, Joel.
So 2 linked questions.
Mhm.
The one where you were comparing various forms of hydrogen to gasoline in terms of gravimetric and volumetric density.
Yes.
The gravimetric densities there were considerably higher than you'd shown earlier. Is
Yes.
that because of the weight of the walls of the tank that is contained in, or why were those gravimetric densities higher?
Those ones were so much higher because in the first plot that I showed was just purely hydrogen. These other ones were incorporating like metals and other aspects. As soon as you put in those metals,
So that,
driving it up.
So, and what I meant to say, I guess, was gravimetric density is low, right?
Oh, yeah.
Yeah. So that leads me to my next question. These various things, the Glathrides and all of those that you were listing,
Yeah.
what would you say would be best case scenario in terms of proportionally how much additional weight we're adding over and above the weight of the hydrogen to be able to transport it around?
Yes, that's the big question on what's economically feasible.
Yeah. I mean, are we quintupling the weight in order to transport it around with these things, or even more?
It's kind of a balancing act with what happens in the oil industry in terms of like what's reasonable and what's not. So gasoline and other fossil fuels are constantly going to tick up.
In price.
What's that?
In price.
In price, yes.
Well, what I'm talking about is just weight,
Oh,
right?
oh,
The
okay.
advantage of hydrogen for like airplanes is that
Yes.
it weighs so little. But if our storage medium is adding 10 times the weight,
Yes.
because there's all the metal and stuff, we lose that advantage. So that's what I meant. What's
Yes.
the best case scenario in terms of how much additional weight we're adding to the weight of the hydrogen to store it through these methods?
The best case scenario is you have some of these higher ordered metal things and you have real low molecular weight containers to try and hold on to that hydrogen rather than utilizing like a metal surface in some case.
To
So-
contain it at high pressure.
Yes.
Yeah.
So there are companies that are currently working on like fiber composites and so on to try to drive that down as much as possible. The strict number, I don't know, but people are working towards it and are getting closer and closer. So I would say, in terms of like, how are we gonna do it? It's probably gonna be through carbon fiber tanks, and we're gonna be doing liquefaction of that hydrogen in some way, shape, or form, or we do an atomistic approach.
And the liquefaction by pressure or by refrigeration or a mix?
Pressure.
Okay.
Pressure is the easiest
Yeah,
way.
okay.
Refrigeration just takes too much energy
Yeah, yeah.
where it's not efficient.
Yeah.
And so this picture, you had like a train and a plane and a
Truck.
steamer,
Oh, okay.
right? So that's being done now.
Yes.
And how are they overcoming the fact that it takes up space?
They're not too concerned with it. They just have tanks on there.
Okay.
What they are concerned with and what companies have approached me about is if one of these should have a mishap and crash into something, you're just gonna level an area. So they're more concerned about the safety, not so much the storage.
Like a city block or a fraction of that?
Probably the plane and the boat, yeah. That guy, you're probably getting half of a block.
So no problem.
Yeah. Depend, well, we're by Green Street, wouldn't make it. I'm kidding. Bad.
What would have happened if I hadn't used gloves?
No, just probably more surface tension in your hands would get all soapy. And if you talk to anybody in my family, like peeling an orange is the worst thing that could ever happen to you. So it's more about.
Okay, so
that
I
kind of
wouldn't have
thing.
burns.
No, you wouldn't have burns at all. Your hands would just be soapy. It'd be terrible. Yeah. Yeah, it's like, I don't know, how many people hate touching a piece of paper after their hands have been wet? Okay, I can't do it, it drives me nuts. Yeah, now you're gonna do it later.
Don't do it often.
Other questions?
So, do you like,
Yeah.
like briefly touch on why you like hydrogen burning internal combustion engines?
Yes.
Why?
That-
It seems ridiculous.
It is ridiculous because the efficiency is truly garbage. At that point, you should be burning gasoline. The thing is that technology exists, it's there. The other thing is okay, Chevron, ExxonMobil, all these other companies are looking at generating hydrogen. They want to make a circular economy so they can continue to make money. They don't want to watch their industries disappear. I don't blame them, provide a lot of jobs and whatnot. The easiest approach, make it workable but not efficient. It's like, why do all your electronics die at 7 years?
Right.
I was part of a think tank where we were trying to develop ways to make organic LEDs die in 7 years. I make money. Yeah.
So I have no science background.
So can hydrogen be found in other galaxies or planets? And if so, do you think that if aliens were real, would they be using that to fly?
That's a deep question. So wait, let me get my alien here ready. Alien.
I think all the aliens are real.
Yeah, aliens are real. Yeah. They're doing an anal probe joke, but we'll stay away from it. So, would they be using hydrogen to get here?
Or anywhere else?
Yeah, I mean, that's what we use when we go to explore planets. I would think yes, because you can use a catalyst where the oxygen and the hydrogen hit one another, and you can generate a really strong jet stream, go pretty fast. I know this is a conventional idea too, but I think we're the most advanced civilization out there. I know it seems crazy because an advanced civilization would doubt that they're the most advanced. That's philosophical. Okay. So would the aliens do that? Yeah, why not? Hydrogen's out there. If they have as much scientific knowledge as we do or more, yeah. Every planet has a large amount of hydrogen on it. The kind of crazy thing in terms of different planets, Jupiter has metallic superconducting hydrogen. It's pressurized to the point. Yep. Yeah.
What makes it metallic?
The pressure. When you squeeze hydrogen to really, really high pressures. Yep, it becomes a solid. It's a solid and it becomes metallic.
Okay.
Yep. Actually, through those diamond anvil cells, they've shown that, and through what are called shockwave experiments.
So it's heavy metal.
Yeah. So I would think that they would. I would think they would hedge their bets. Go with the cheapest thing out there because why not?
Not just anybody.
No, that's, so I also have no science background, so.
Okay. Are we gonna talk about aliens because we keep going?
But my question is kind of a weird one, but, so do you eventually see, so let's say that we develop something that would work on our planet, that would be effective, that would be efficient. Could you see eventually mining some of that on other planets? Would that be something?
Oh, like the hydrogen? I mean,
Yeah.
I think we're gonna ditch this planet as soon as we can.
Yeah.
I don't know, what was that, the movie Don't Look Up, where all the rich
Yeah.
people at the end were like, nerds!
But they're
And
all
Interstellar. No, Interstellar, that's the worst movie to watch on Christmas.
Wally.
I think we'll be ditching the planet before we're mining it, and at this point, it's so plentiful that there's almost no point to mine it.
Oh, okay.
What I do have to say about that, though, let me get to the slide about. Oh my God! All right, we're going through all this stuff again. So numbers.
Yay.
This thing, green. So it is sort of current hydrogen is sort of mined because the main source comes from fossil fuels.
Okay.
Okay, so all the hydrogen, especially for the Haber-Bosch process, comes from fossil fuels. Your fertilizers all come from fossil fuels. If we don't have that chemical reaction happening, like I said, 80% of your nitrogen is not here. 80% of the world's population goes into starvation. It's almost Friday, let's be happy. Does that answer your question?
Yes, thank you, it
Okay.
does.
Sorry, I'm always a down. I work on really downer stuff.
Any other questions? Green and purple pink.
Yeah, actually, this is red. I don't like purple and pink. It's red.
Definitely
Yeah.
not red.
And then, and I really don't know why yellow is all that different from green and other spots too. I don't know. A lot of people just want to have the coolest color of hydrogen.
Yellow is a mix, right?
What's that? Yellow can be a mix. So I guess, but it's like, why don't you just say you're producing green/blue?
Yeah, right, yeah.
Yeah. Making it more complicated than it needs to be. Any other questions? So next time I talk to you guys, I'll talk to something more depressing than this. So.
Thank you all for coming. Tip your server. He's been really great, I think.
Yeah.
Yeah, he's
Very
great.
attentive. And join us February 9th for our next Science on Tap, when Caitlin Dykstra is gonna talk to us.
Dykstra.
Something about cancer.
Good girl.
February 9th.
February 9th, mark your calendars.